All right, part 3 and about the end of our discussion. We have seen what happens when a number inserted in this position, I'll call it A, if y equals a sine of theta, A will dictate the amplitude change, and the sign of it, the SIGN of it, will tell you whether you have a regular sine curve or cosine curve, or whether it has been transformed by flipping, or it's been reflected. We could say flip is another word for reflected across the y-axis. All right, so the last thing I want to show you is sometimes we not only insert a number there, we insert a number here. And I was wondering, and I'm sure you were as well, what that would do. This changes the amplitude. We're going to remove that on our discussion. We can definitely have both a number change here and here, but we'll just talk about when we have a number change right here. That number has something to do with the period. The period so far has always been 2 pi. So if I have a regular curve, pi over 2, pi 3, pi over 2, 2 pi. If I have a regular sine curve with a period of 1, it goes up to 1, down to minus 1. I'm starting my timer, I'm sorry. So here we go. Here's a regular sine curve. What if I took that curve and I squished it? Instead of having one mountain and one valley in 2 pi radians, what if I had one mountain and one valley in pi radians? And of course that would continue like that, but notice one peak and one valley took place in pi radians instead of 2 pi radians. This number here would be altered. And what happens here, it's not as easy as amplitude in that you just look at the number and you can see the new amplitude. You have to know this is pointing to a key. So the key for understanding the period change is this: B always equals 2 pi divided by the period. So in this one, we knew that the period, one peak and one valley, took place in pi radians. So I can put in a pi there. So I get B equals 2 pi divided by the period, which is known in this case. Those cancel and I get a B of 2. So if I go back over here, I can alter this equation by putting a 2 where the B was. So what the 2 does there is it actually takes the period, the normal period, and cuts it in half. So a period of 2 pi becomes a period of pi when you put a 2 there. So let's talk about another one. Suppose we have y equals cosine of 3 theta. So I know that the period has been messed with, and I know this is the relationship. That number right there is my B. So B equals 2 pi over period. That's the key. This time, I don't know what the period is, and I need to draw this function. And to do that, I have this number, which is B. So I can put it in this spot. So I have 3 equals 2 pi divided by the period. So solve that for P, multiply both sides by P, and divide by 3. So we get a period of 2/3 pi. So let me graph, I'll just put in a pi instead of pi over 2 and pi and 2 pi. Because it's easier to find 2/3 pi if I just have this here. I know pi over 2 is in here, but I'm not going to put that in right now, because about 2/3 of the way over to pi, which looks like about there, I have to have my whole curve. So my whole curve is going to have to fit in 2/3 pi. So it's going to go up to 1 and down to -1. Oh, I'm sorry, this is a cosine curve. So cosine curve, you remember, starts at top. So it's going to go half of a mountain, a whole valley, and then the other half of the mountain within 2/3 pi. So right there I have the whole period squished within 2/3 pi, and that's going to continue like that on both sides. All right, that's a pretty good introduction to what we're looking at. Ah, you just fell over. I will do the grand terrific finale, and let me see. I'll go back to that in a minute. What if I put them both together? What if I have 5 sine of 4 theta? I will show you how that would work. I think pi over 2 won't be confusing this time, so I'll put them all in. I know the period has changed, so I'm going to go from 1 to 5. So I'll say this is 5 and this is -5. And the 4, I use my little key, period equals 2 pi divided by, b equals 2 pi divided by the period. I know my b, it's sitting right there, so I solve this by replacing b with 4 and solving for the period. And I get period equals 2 pi over 4, or that reduces to pi over 2. So that's a nicer one to work with. So the whole period is going to fit 1 peak and 1 valley within pi over 2 radians. So it starts here as sine does, peaks at 5, bottoms out, and comes back up at pi over 2. So quite squished. All right. That's enough for tonight. I wanted to show you my spider web, and actually I didn't complete it up here when we were looking at the various values of cosine that were increasing. I wanted to show you cosine was doing this, and then when I went down here and continued around, I had the values of sine, again, darkened. And as I went around like that, I thought it looked like Charlotte's Web. So, let's see if I have anything darker than that. Let's just write across it. T, double E, double R, double I, double F, double F, double I, double C. Terrific. All right, you have a terrific night, and I will see you a la mañana. Good night.